why is it important for us to filter traffic within the enterprise or within a network? So we are on chapter 8, which is filtering traffic. Okay, so let's start. Okay, so just like the objectives. Now we should describe traffic, okay, and filtering, and explain how access lists (ACLs) can filter traffic at a router. Now we should analyze the use of the wildcard mask also, right? Wildcard mask, because we're using wildcard mask in our access list statements all the way. Right? We don't use the default standard mask, but we use the wildcard mask. Now we should configure and implement access list as well. Now create and apply access list. To control specific type of what? Of traffic. Now log access list activities and integrate access list best practices. Okay. Now create and apply access list, okay, to control specific types of traffic. That means this to say that with access list we can actually prioritize our network. We can actually specify the type of traffic that will flow on our network. Okay, maybe a TCP something. Okay, or UDP. Okay, so we're going to look at how we can actually filter traffic based on applications, right, services, okay, and all those stuff. So access list is going to help us. So let's begin our journey for access list. Okay. Now within every network, okay. Now networks are set up just to share information, okay. Now, if that is so, do we say that because of that, we should allow every other person to participate on our network? Okay, so I think access list is one of the best tools, okay, in our networks. One of the best mechanisms we can ever get in a network, because it kind of puts a boundary within a router that allows only legitimate users access. Now, not only that, you can actually filter that people or those people on the network just to access or deny them a particular service. So access is very fun, right? Now, analyze the content of a packet. Now, a packet, depending on the packet type, okay, let's say this is a source. So our source, these are our destination. So this is S and this is D. Okay. Now, the packet that will be sent from, let's say this PC1 to router 1 has to be a specific packet. Okay. Now it's requesting for something or an application or a service. Okay. Now within this packet, that service is what? Is embedded in that packet. Alright, so let's say this, okay, is connected to what? A web server here. Right? And PC1 wants to access that web server. Within the packet frame of this PC, okay, is what? The destination. The destination port number of the web server, which is okay, within the packet frame of PC1, okay, is the destination port number or the application. Now we know web servers run on which port? Web servers 80, okay, or the application they run on is what? The 8 TTP, okay. Now so that is why we have to analyze the packet, okay. Now An access list, okay, also does this. Now, after he has analyzed the packet to see which packet it is, it actually allows the packet or it denies the packet. It allows the packet or it denies the packet. Alright? Now, based on source IP, based on destination IP, based on MAC addresses, based on protocols, based on application type, access list will either deny or permit. An access list will deny a packet based on the source IP or the destination IP, the MAC address, okay, or a protocol, and even sometimes an application. But a protocol, we know TCP, it's a protocol. Okay, so we can say that the packet from PC1 is a TCP what? Protocol. And to the destination, which has what? And a what? A TTP what? Application. This is actually the source, let's say IP, and that is what? The destination IP. So you can see how access list does it, okay? It can be based on the source IP address, can be based on a protocol, the destination IP address, and sometimes also the application, right? Sometimes you can even allow or deny by using your MAC address, okay? So this is how access list kind of works, right? So let's look at this on the screen. And you can see the application over there is what? The protocol is what? It's HTTP. A network is a network, okay? Tenant access. And the IP, the source IP is a particular packet, okay, to the destination. Okay, so let's continue. Now, device providing packet filtering, right? Now, one device that can filter our network is what? Is a firewall. Now, a firewall can be a dedicated firewall, right? That device is just for filtering purposes. Okay, it can be a dedicated firewall. It is just there for security reasons. And now these devices are very, very, very expensive. Sometimes corporate bodies can't afford it, so they kind of lease it, okay, on maybe yearly basis, or maybe it depends on your budget, right? So a firewall can be a dedicated firewall. That means it has no other what duty on the network than what? Just filtering purposes. Okay. Now we also have what do you say? Firewall building to what? Integrated what? Routers, just like our Linksys. Our Linksys has a firewall, okay, built in it, right? So our integrated service routers also may have the services of what? Firewall embedded in them, just for security reasons, just for filtering reasons. Now sometimes with servers, okay, server-based firewalls are also a source of filtering on our network. And sometimes our Cisco routers, depending on our iOS, okay, also supports filtering, okay, or they are embedded with what? Firewall services. Okay. Now let's move on. Now, uses of access list, okay? Now, we either need to specify internal hosts for NAT, Okay. Now it is also used to classify what? Traffic for quality of service. We'll talk about that another time. Okay. Now we give one service a priority, or one traffic a priority over the other. Okay, so one has a higher priority than the other. That means that guy will be given a higher attention compared to the one with a lower priority. Okay, just like maybe voice over IP compared to a normal data traffic. Okay, right. Now we also restrict routing updates. We limit debug outputs. Right. We also control our virtual terminals access. Okay, we can actually use access list to do what? To block or to filter our VTY. Our VTY access list is used to filter it. Now this is you can actually allow only a particular IP address access to your VTY. If any other person, a hacker or somebody, tries to get access to that VTY because it's not part of that IP address or maybe that network, it automatically not be allowed. It's not be allowed to even access to, because access list will just block it. Alright, so access on our line VTY and our line console also very, very important that we should look for. Now, if you create a line VTY, right, or a terminal line without putting an access list, okay, now somebody can actually be trying, right, just trying to get access to it. Alright, now the person might succeed. Maybe the person trying to key in a different password or something, just trying. Maybe the person can actually succeed. But with access list, the person will not be allowed to try. Because you are virtually not part of the list we've permitted to access our line VTY. So therefore, you are not even allowed. So anytime we create our line VTY, our line console, anytime we open those lines, we should make sure that immediately we put access list on that line. Now, those people, the people that will be on the access list on, let's say, a line VTY could be the technicians, okay, or maybe it could be the CCNA guys, right? Those are the guys we allow them on the access the line VTY, just for inbound or outbound configuration or management purposes, right? So we allow these guys access to our line VTY. All right. So let's continue. Now some possible reasons for access list. Okay. Now it actually increases the load, okay, on the router. All right. Now when anytime we configure access list, now we've kind of given another dedicated service to the router. Okay. Now the router is also supposed to route packets and at the same time filter packets. Okay, so it kind of increases the workload on the router. So if you don't have a powerful router, okay, we configure access list, the workload on the router now becomes a bit cumbersome. Right now, because it's trying to route packets over to other from LAN to LAN, and it's also doing what? Also filtering packets. Alright, okay. Also, there's a possibility that networks will be what? Will be disrupted. Okay, so network disruption. Okay, without access list in place, the possibility that network can be disrupted, right? Some hitches here and there is a bit high. Okay, now one major problem with access list is the placement. Okay, if you don't place access list on a correct path or on a correct interface, we actually mess up our whole network. Alright, so we should be very careful anytime we are planning our access list. We should know where we are placing the access list, because an incorrect placement will result in what? A doom. Kind of one statement will just kind of bring all your networks down to zero because you didn't place the access list where you were supposed to place it. Okay, so that is also very important. Let's look at the kind of the types of access lists we have and how we configure them. Now, we have basically 3 types of access list. Okay, 3 types, 3. As Cisco iOS is concerned, and the others is concerned, we have only 3 types for now. Right? Now we have the standard access list. Alright? We have the extended access list. We have the name access list. Now all these guys are different access lists, and they filter or they are used for different purposes. Now let's look at the first one, which is the standard access list. Okay, the standard access list. Let's look at how it works. Now, standard access list, okay? It filters a packet, okay, based on the source IP address. It's as simple as that. Okay. Now, how do you know you are creating a standard access list? How do you know you are creating a standard access list? What you do is it has a unique grouping of what? From 1 to what? 100. So anytime you see this grouping, we know that this is what? The standard access list. Okay. Now we say it filters a packet or a traffic based on 99. Sorry. Yes, it's 99. Sorry. Excuse me. Sorry about that. 1 to 99. Yeah. Alright. 1 to 99. Right. Thank you for that correction. Okay. So it filters a packet based on what? The source IP address. So let's just take let's see a scenario. Okay. This is a switch. This is a router. Okay. Now this is our web server here. Now, this is our, let's say F30/1, and this is the out, okay, F30/0. Then, there's a guy here, okay, now it's a PC, okay, now, they want to access this guy, web server, but we want to actually deny, okay, let's say we have 2 guys here, PC2 and PC1. We want to actually allow this PC, and deny this PC. Okay? Now this guy is a stubborn guy on the internet, on our network. He's always accessing the web server. Okay, so we want to stop him. We just want to allow this guy access to the web server. So we can actually do this by using a statement. Okay? Now what do we do? Access list. Then we specify which are we creating. Is it a standard, extended, or a name access list? Then we do what? Access list. The group number is what? For extended is what? From 1 to 99. So we just specify any number from 1 to 99. Okay, so we can actually say access list what? 1. Meaning that we are creating a standard access list. Okay? Now, yes, 1. So what are we doing in the 1? We want to permit PC this guy. Now let's give it an IP address, okay? 192.168.100.2. And this guy is 192.168.100.3, okay? Yeah. Now we actually want to allow PC to access to the web server. Okay? Then we deny this guy. So what do? We do this access is 1, then we bring our permits, our statements, okay? Permit. Okay? It's a host. It's a host. Okay? Permit host. And the host, what's the ID, the IP address is what? 192.168.100.2. Okay? On what or which subnet or which subnet mask. Okay, remember that in access list we don't use subnet mask, we use what? Wildcard mask. Okay, so you actually specify our wildcard mask on /24. Okay, so it's what? It's what? 0.0.0.255. Specify that this guy is on the /24 network. Okay, yes, out of this release. Access list 1 permit host what? 191.100.20 on the /24 network. You permitted it. Okay. Now this is how far an externalist can go, because it's designed to only allow, okay, or permit based on a source IP address. So this is how far an externalist can go. We can't extend, we can't add a protocol, we can't add an application. Okay, this is how far it can go. Now after this, it means that we've kind of allowed this guy. Okay, now let me just say it, that at the end of every statement, alright, another statement, there is what we call an implicit deny. It means that after every statement you've configured, there is a deny automatically, virtually, that you can see. That means every other statement you've done here, there's a last statement which is what? Denied by the router. Okay, now so if you do this, you virtually allow only this guy on the network. The other guys are all denied. Okay, do you get it? Now we can actually manually deny this guy. Okay, we just kind of do it again, and we do access list 1 deny host, then we deny this guy. Right? Right? That's how we have done it. Then we actually denied this guy and permitted this guy. Now, after we do this, how do we implement the access list? Where do we put it? Okay, yes. We place an access list on an interface. Okay, how? Now, it's either placed inboundly or outbound. Right? Inbound to your network and outbound outside your network. Okay, so we place an access list on an interface. Right? Now, this is what we want to do. Now, where do we put our access list? Where do we place our access list? Where do we put it? It will be on the router here. Okay, now, should it be placed inbound or outbound? Now, inbound is to the network, to our local LAN. That is this. Now, outbound is here. So this is out and this is in.
So access list, standard access, I think it's best practice to place it to be close to the
Yes.
destination.
Yes.
Then we go to the outbound.
Sure. So we actually put it on the outbound because it's kind of close to the destination, right? Now, if you put it here, it will still work. Okay, it will work. Okay, but advisably, let's just put it close to our destination. So we put our access list. We put our access list to close to our what? Destination. Now, how do we implement it? We will go to our interface. Okay, then we will key in the command access list. Now, is it access to access group? Yes. It's access group. Then we'll bring our grouping, right? Yes, so that is 1, okay, for this access list. Then we do what? Access list, access group what? 1. Then we enter. Okay, then inbound. Very outbound. Is it outbound? out. So we say access group 1 out. On the interface 0/0, that let's say this R1 on RS1 interface 0/0. If you do this, automatically this will not be able to access the web server, but this will access. Okay, so that is how access list kind of standard access list kind of works. Okay, all right. So let's move on.